Welcome to our Technodyne Tech Talk. Today we're going to discuss fiber morphology and its value to you. My name is Adam Hauser. I've been working with Technodyne for about 3.5 years now after graduating from Auburn University, War Eagle. In utilizing fiber morphology and production optimization, those fiber properties most commonly measured are length, width, kink, curl, coarseness, fibrillation index, as well as the percentage of those broken ends in your furnish. When we focus on natural fibers, other key parameters that influence the consistency of production are fines volume, hardwood-softwood ratios, as well as the chives content of a given sample. In the production of web products, those elements of the furnish most commonly measured are fibers, fines, as well as chives, where a fiber is typically defined as any element whose length is greater than 200 microns or less than 10 millimeters, and whose width is greater than 5 microns but less than 75 microns. A fine is typically defined as any element whose length is less than 200 microns, and a chive is typically defined as any element whose width is greater than 75 microns, but whose length is also at least 3 times as long as it is wide. Here we have a visual example of a fiber as well as fines, and those other commonly measured fiber morphological properties, such as curl, who is the length of the fiber relative to the overall curvature of the fiber, as well as kink, which are elements on a fiber that reach a certain acute angle threshold. We can also see here fibrillation, which is used in the measurement of the fibrillation index, which is the length of those fibrils relative to the overall length of the fiber, as well as we can see broken ends here that occur in the length shortening of fibers throughout your production process. The objective measurement of morphological properties can help you improve refining, formation, paper chemistry in order to ultimately minimize cull and improve efficiency. We'll show you how in the next few slides. A solution for the objective measurement of fiber properties has been developed by cooperation between the industry and CTP. TechPap, who's the commercial arm of CTP, manufactures the device in Grenoble, France, while we here at Technodyne provide service, marketing, and technical application support in North America. The Morphe Neo Compact is used for the measurement of fibers, vessels, chives, and fines per the ISO 160-65-2 standard, or you can also use it to measure fiber ratios based on your mill's definition. Here, we have an image of what the Morphe actually sees, and visually we can see clearly fibers versus fines in the sample, or here we can clearly see chives. Based on industry feedback and research by the CTP, we've also developed new features for the Morphe Compact Neo. These include a vessel recognition software, which is an automated process for identifying and counting vessels in your sample, as well as a physically separate high-res module that allows for the measurement of cell wall thickness, as well as a determination of microfibrillated cellulose behavior under different chemical additive conditions. With the Morphe Compact Neo, you can automatically test up to 5 samples for the morphological analysis of raw materials, your fiber samples throughout the wet end of the production process, as well as the finished product when made back into a pulp solution. It's a powerful tool for increasing the efficiency and reducing material costs in your production. We do this by improving machine runnability, allowing you to grade raw materials, optimizing the refining process to reduce cost, improving the wet end chemistry and additive process, as well as decreasing product development time and cost. Based on our experience in the industry, we've identified these 5 areas as those where you can find the most value immediately by using the Morphe Neo Compact. We can improve machine runnability by allowing you the optimal understanding of your process from the wet end to the finished product. This enables you to minimize paper breaks, maintaining uptime, as well as reducing cull and customer rejects, thereby reducing cost.
An often overlooked opportunity for potential improvement is in that of raw material grading. Fiber morphology data can be used to ensure quality standards of furnish supplied to you. With this data, you can also build predictive models of your process, potentially reducing cost and downtime associated with refining and wet end chemistry inefficiencies, as well as the head box adjustment period.
Another opportunity for value we found is in the optimization of your refiners. You can reduce the energy cost of your refining process by utilizing the device to find potential inefficiencies in your refining process. You can also reduce material costs by finding more efficient fiber blends or chemical treatment processes without sacrificing finished product quality. It has been proven with effective fiber analysis that large long-term cost savings can be extracted by measuring fiber properties under various conditions in order to identify potential inefficiencies or find improved chemical treatment procedures. Usually the most problematic justification for new product development are the time, cost, and man-hours associated with it. By utilizing the Morphe Neo Compact, you're enabled an objective and automated test solution. Combining this quick test method with predictive modeling, you can remove the time, cost, and man-hours associated with improving your existing production methods and developing new products. We hope we've shed some light on the importance of fiber morphology and its potential value to you. If you have any questions for us here at Technodine, please do reach out. Otherwise, we'll look forward to hearing from you and the opportunity to serve you. Thank you.